Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammed Haqiemee bin Mohd Unsein. My matric card number is B091910186. My supervisor name is Dr. ROSIDAH binti JAAFAR. For this Bachelor Degree Project 1, coded BMMU 3764, I will present my study research titled Investigate the Finite Element Mesh Generative of Ladder Frame Chassis Structure using Finite Element Method to my two panel that are IR TS Dr. LAILATUL HARINA binti PAIJAN and TS MOHAMMAD HAFIZI bin RAHMAN. For the presentation outline, this presentation consists of introduction, problem statement, objective, scope of research, literature review, methodology, expected result, and lastly conclusion. For the introduction of this thesis, the Ford F150 Raptor is the best of road performance pickup truck that was inspired by trophy trucks and desert races to drive quickly over any terrain. The Raptor was purpose-built for hardcore off-roading with a model exclusive suspension arrangement and a wider track than a regular F150, and makes the current Ford F150 Raptor Special is nearly 500 pounds. That was estimated as 225.796 kg lighter than the previous version, thanks to the uses of high-strength military-grade aluminium alloy body. So, a chassis is required for the body construction of the Ford Raptor pickup truck. In general, a chassis is a foundation structure that supports the components that are attached to it. In this example, a ladder frame chassis is chosen since it is reasonably inexpensive and simple to fabricate for manufacturing purpose. Because the vehicle is designed to carry a heavier load, the chassis must be capable of withstanding it. So in this thesis, the ladder chassis should be developed with the specified load and dimension to meet the approvable standard. As for the problem statement, due to the ladder chassis vehicle inadequate torsional rigidity, cornering is always a concern. Turning in emergency maneuvers also quite difficult due to the vehicle's heavier loads. The use of extremely sturdy steel as the chassis also becoming the problem when it's come to its performance and fuel efficiency. Changing the engine to improve vehicle performance is a time-consuming and expensive task. Changing the aerodynamic brakes by lowering the vehicle weight is highly recommended. The chassis is a critical structures component that ensure the vehicle's integrity. So if the chassis weight can be lowered while still meeting structural standard, the car's performance can be improved significantly. Automobile manufacturers have recently focused their research on making their chassis lighter and designing the chassis with a variety of material. So in this thesis, we will differentiate between two materials for the ladder frame chassis. The objective of this study is to conduct literature survey on ladder frame chassis and its material, design methodology for designing ladder frame chassis through CATIA V5R21, study the finite element structural analysis through CATIA V5R21, study the difference between two selected different material, study the deformation visual on CATIA V5R21 and Alter Inspire, and lastly, analyzing the ladder frame chassis to CATIA V5R21 and Inspire. The scope of research in this study is designing the ladder chassis frame with CATIA V5R21, analyzing the design ladder frame with Altair Inspire and CATIA V5R21. And then lastly, analyzing the different results obtained between two materials that are low carbon steel A36 and high strength low alloy HSLA80. For literature review, firstly, we would like to conduct an investigation of ladder frame cases. Okay, the ladder frame cases is one of the oldest and simplest cases ever invented that got its name from resembling the shape of a ladder. Two longitudinal components called longitudinal rails make up the ladder chassis frame. A series of shorter components known as cross members link these longitudinal rails laterally to give strength and prevent the frame from twisting. Cross members are joined to these longitudinal rails. The ladder frame case's main selling feature was how simple it was to construct, prompting automakers to employ it in the production of pickup trucks. The objective of the ladder frame cases is to keep the vehicle safe under the given load condition and improving the performance of the vehicle. The disadvantages of ladder cases is being heavy that can lead to extra fuel consumption. In this slide, I would talk about the different properties of both material used in this study. Firstly, the low carbon steel. When it comes to building cases, low carbon steel always preferable by the vehicle manufacturers due to its mechanical resistance, heat resistant durability, and production simplicity. As a result of its material qualities, low carbon steel are employed in market for a wide range in automobile. In this study, low carbon steel is employed to make ladder cases frame. Low carbon steel is classified by having less than 0.3% of carbon by weight. A36 steel also generally used in making ladder steel frame as it is extremely useful as a general purpose steel that are easily machined, welded, and formed. Material properties of low carbon steel A36 is shown below on the left table. Meanwhile, HSLA80, also known as high steel low alloy, is an alloy steel that has a better mechanical qualities and corrosion resistance than carbon steel. HSLA steel differs from other steel because they are designed to meet mechanical qualities rather than chemical composition. They are usually found in automobiles, trucks, cranes, bridges, roller coasters, and other structures that must withstand high load or have a high strength to weight ratio. Cross-section and structure made with HSLA steel are typically 20 to 30% lighter than carbon steel of 20 comparable strength. HSLA less than 0.15% carbon. The microstructural constituents of HSLA steel are similar to those of plain carbon steel, but the ferrite grain size is far smaller. Because of the microalloying addition and special processing due to the advantage of SLA, automobile companies can manufacture the automobile parts to make a lightweight vehicle. HSLA was also used in the construction of the Ford Raptor ladder frame cases. As for the properties of the high strength low alloy, you can see it in the right side of the table. Okay, the difference between low carbon steel and high strength low alloy is that it is different from the density, modulus of axillity. The position ratio is the same. The yield strength also show different value, which is higher on the high strength low alloy. The different value between the tensile strength shows that high strength low alloy consists of higher tensile strength compared to low carbon steel. In this slide, I would like to talk about the designing and analyzing software that are used. One of the software that are used in CATIA V5R21. The software is chosen because it creates orthographic, isometric, and detailed two-dimensional drawing views. The drawing views can be referenced and model dimensions can be generated. This program covers a wide number of industries, including design from start to finish, a wide range of scan, simulation, and optimization drawing, and program for manufacturing. For the last software, that is the LA Inspire. The advantage of the software are it can assemble larger and complicated parts and analyze the part using structural analysis. With the speed and accuracy of ALT-A SimSolid, users can run dynamic motion simulation, including load extraction, by using ALT-A Motion Soft Dependable Multi-Body System Analysis. And now I would like to talk about methodology. As you all can see, this is the flow chart of the project of this study. In this slide, I would like to talk about the design of ladder frame cases. The design started from the general sketching of the ladder frame model by hand. By sketching the ladder frame, it gives clear picture of the diameter and why the ladder frame design is developed in that way. Then the optimal parameter of model is searched out by referring past research and referring to automotive manufacturer manual. Then the design finally developed by using CATIA V5R21. When the drawing is complete, the material is applied by selecting part body features and apply it with the selected material. In this slide, I would like to present about the design analysis. The design analysis uses finite element analysis to stimulate the physical behavior of ladder frame cases in the study. The finite element analysis approach entails breakdown all system into separate component or element with easily understandable behaviors, and then decreasing the original system from the component involved. The design analysis started with CATIA V5R21 when the von Mises stress is conducted to find the yield force of the ladder frame that I had created. Then the ladder frame that had been created with CATIA will be exported to ALT-A Inspire to analyze the displacement, factor of safety, percent of yield, and max shear force of each material used. In this slide, I would like to talk about the expected result from this study. In this study, we will expect that high steel low alloy ladder frame cases will have high von Mises stress compared to low alloy ladder frame cases. Secondly, we will expect that high steel low alloy would withstand heavier load. Thirdly, that the factor of safety of high steel low alloy ladder frame better compared to low carbon alloy ladder frame. And fourthly, we expect that percent of yield is higher in high steel low alloy ladder frame compared to low carbon alloy. And lastly, for the conclusion of the study, this study aims to learn and find more about the design of ladder frame cases and its materials. This study can determine the problem having in vehicle, mainly the pickup truck, focusing on the material that was used to build the chassis. When the problem is identified, it can help many production in view the material used to construct rather than modifying other part of the vehicle for weight reduction. In PSM2, further research will be concluded to fulfill the defined objective of this project. Okay, thank you. That's all from me.